subtract it, get the distance of that. We want to project onto this vector, so that's going to be we're going to need the dot of itself. We're going to want another dot. We need the dot of B. We're projecting onto this vector, so we need to multiply and then we get the distance of that. And that should go from 0 to 1? What the hell? Alright, well, I'll be right back. Well, for our angle here, is this actually correct? Like, if we rotated this thing, if I wanted this to go from 0 to 1, we're projecting onto 7, 7, which is straight out, which is that direction, which is not what we want. We want negative 0.7 would be that direction in this direction, so it would be there. So this is actually supposed to be a negative 0.7 for us to do this. We need to make a material function here. Project onto function. I'm surprised they don't already have this. So how do we make that before? It was in like graphics. What is this? Why are there test materials inside of here? It should be inside of your test materials. Who added these? Yeah, these should be inside of here. It should be new folder. Should call it decals, and we're gonna throw our test stuff in there because test content goes in the fucking test directory. And this was our material function. Alright, so we need to go material function. We're going to call this project onto. And what are we going to take in? We're going to take a vector 3. Yeah. Alright, so we need to dot, this will be input in, which should be project onto, and this will be input. Alright, I'll do that opposite, so the input, and this will be input. Okay, so what we're going to do is we're going to dot the project onto vector by this one, and then we need to multiply that by this vector, and this vector needs to be dotted with itself, and then we divide. So I'm going to say project onto projecting 1 onto 1. So we're going to definitely save this. Previewing material expression. Where the hell is the name for this thing? It's called the project onto function. How do we... there it is. Alright. Material function is project onto expose to library. How come sort priority? Let's say 1. Okay, why isn't this fucking sort function? What is this? Sort priority controls the input is displayed relative to other inputs. Well, I get that it's supposed to. Do I have to hit apply and save or what? Stupid. Like the documentation says this controls what it, how it shows up, and then it doesn't. Alright, so our project onto, at least we have the names. It should just be white like that. And this should go from 0 to 1, and this should be just something divided by that, so it'll go from 0 to whatever value that's supposed to be. It goes from 0 to 1, right? Should go from 0 to 1. I guess that is from 0 to 1. So we're going to take the Alright, let's see. That goes from 0 to 1, that's true. Alright, we're supposed to have this component here Alright, maybe that's what we're supposed to be doing here. Well, let's see if that's correct or not. Shit. Holy shit, it's actually consistent. It's just flowing into the wrong place on the so the U is wrong, but it's because of some other reason. The basis is point negative. Negative 707, 707. Okay, so as this thing goes down the slope, because it starts off at 0 here properly, but then we've got something wrong with our equation for figuring out the width of this thing. So what do we do here? We've got our V, and so we got our V that goes from what value? It goes from 0 to 1. And what is this right here? This is our U value wrong? Is that what's going on here? The U value needs to be added to somewhere here. got our color combination, which is based off of Alright, so we go from 0 to 1. When we add these together, what are we getting? So it goes from 0, breakout, flow 2. Alright, it's supposed to go from 0 to 1. That's going from 0 to 1. So in preview it goes from 0 to 1, 0 to 1. Well, that's 0, 0. Is that actually 0 to 1? Projection of B onto A. If the vector A is projected onto B, then the vector projection is given by Alright, so it's 181, 128. How come this doesn't have a V3 here? It doesn't say input. That is just weird. That there's no input on there, there's no name for it. Well, I guess we should also make a scalar projection vector thing. Which is supposed to be defined by, we have the input, we have the project onto, and the output is a scalar, so it's going to be I really hate it when they use like a dot in a math formula because you don't know if it means dot product or not. And this is projecting onto A, so I think I've got my things reversed in my formula. I think I've got it all wrong. If A is projected onto B, then we need the so the scalar projection should be 0. I mean, should be 1, so that's correct for the scalar projection. Alright, and what's going on here is this projection is wrong. We're supposed to be... The project onto is supposed to be what we're dividing. So it's supposed to be that divided by that. Then it's A dot B multiplied by B. let's see. That's starting to look more like what it should look like. Math, right? How does it work? Alright. We can now rotate our waterfalls. And it works. We did it. We did it. Jesus Christ. It only took us 3.5 hours to figure this shit out. Ah. What? Okay, so and the reason everything was screwed up was because I wasn't projecting the vector properly, and we needed the actual vector projection code here to be available so we could use it. So why don't we use our project onto scalar thing here? And see how that looks. Like, this is supposed to be A dot B over the magnitude of A. So it's the magnitude of A, and we have A dot B, and that's supposed to give us our scalar. Does the scalar projection formula not work here? It's supposed to be A dot B divided by the magnitude of A. That's A dot B right there. Divided by that. I think this has a bug in it. I think they meant to do that. Aha, see, math site? Oh man, that's fucking nasty. So I'm looking at this website here because I'm super smart, right? This vector projection formula, so I was looking at the scalar projection formula there. That formula is wrong. They fucked it up. The A magnitude there is not A. It's supposed to be B on the second formula. So everybody who goes to this website is screwed. It's like, you know, your first hit on Google for scalar projection formula. And so that's like, if you look at it, right, you know, the vector projection formula is A dot B multiplied by B divided by, you know, B squared or whatever. And they're like, oh, well, the scalar projection is defined by this other thing. And if you just like look at this math real quick, it's very obvious that all you do is you're dividing by the magnitude of B, you know, because you slash the B's out, right? So it should be B times B times B, or, you know, or whatever. And, you know, B divided by B squared. Well, if you don't care about the sign of it, you know, you're just caring about the scalar value. Yeah, so that's no fun. If you're in high school or something and you're doing vector projections and you go to that website, you know, you're not going to have a good grade on your math test. And that's part of the cool thing about coding and all that, is when you code something out, it has to be right. You know, like, you can't fuck it up. You have to actually understand it, because otherwise you wouldn't be able to program it. Alright, so one of the things we can't do right now is we can't rotate this thing like that, because as soon as it gets rotated right, it's trash. Let's make it so we can rotate in the Z direction. Do we care about rotating in the Z direction? I mean, it's still water that's falling. Yeah, we probably should care about rotating in the Z. So let's go ahead and do that. Alright, so we're to get our Z, we're supposed to go from what, 0 to 1 on this thing? On our cube. So we're supposed to take our 0 to 1, so that means that we're going to divide by this. It's going to be, well, like our top right, we're going to subtract the top right. Wait, what the fuck are we doing? We're going to get our total value. Alright, so this is supposed to be the world position. Alright, this value here is supposed to be the top right. It's hard to see exactly where it goes. And that's the bottom left. So it's supposed to go like this. From 0 to 1. And then we'll clean this up. God, what a freaking mess. I mean, that's gotta be like the worst thing ever, right? You're like messing around with your homework and everything else. And you go to some math site to get help and you get even more confused. It's gotta be the worst. Alright, so the reason this isn't moving is because we specifically don't ever use those. So what is this? We have the world position. We can just clean up all these nodes that we don't use. Alright, so I need this top right. So just organize this so that it's stupid piece of crap. That sometimes when you click on this, see it's got like 3 different highlight states, which is just insane. Where you click on it and then you click on it again, but after you've copy pasted it's like double clicked. You can see it's actually darker than the normal selection. Well, I mean, it's a lot easier to find a mistake when you got a waterfall that's like not correct looking, right? But when you're just working on your math homework there, how the hell are you supposed to know that that number is wrong? You're just like, all right, well the answer's 5 or whatever, and you go check and the answer was 7. You're just like, I have no idea. Why is the number wrong? Because there's no visualization unless you actually like sat there with graph paper and drew it out. You'd be pretty much hosed. Alright, so if we want to support the other rotations, we're going to want to do this to rotate all those, and we're also going to want to rotate all of this. Well, supposedly we are. Does your game have a concept of tick, or are you working in a higher abstraction level? I'm not sure what your question really is there, Kinto456, with, as in, do all objects have an update function? And we do the classic, game loop of, you know, that basically, I mean, I can just pull up the game loop. Where is all this crap? Dev. You know, like if this is your classic game loop, your update loop, which is like, you know, clear the screen, update everything, you know, update your input, update your utilities, update your game, and then draw your game, right? Actual code. I know, what the fuck. Oh, why? What have we done? But this is a game loop for, you know, that powers this game. Speakers. You know, this game is totally powered by it. Of course, you have to have an Xbox controller to play this. But, you know, like this game is powered entirely by that loop. But in Unreal, what they've got is they've got these different tick events. So like when you go to something that has to update, why is this all fucked up? Like if we go to our character, bitey, movement controller, if we go to his movement controller, we've got like, you know, we've got on update and all that stuff. So Unreal has all these update ticks, and the ticks are broken up into different sections. So there's like, I added one called pre-update. There's basically like update, pre-update. There's like post-physics, after physics, stuff like that. And it's kind of the same thing that Unreal has. I mean, Unity has, where they have the update events that get thrown and everything else. And Unreal does it all like in serial. So one object gets updated after the other, everything like that. It's pretty simple. And the order isn't guaranteed.